All right, so in this video, I'm going to do examples A and B here. Hopefully you watched the last video and got all the degrees listed already, but I'll briefly touch on those again. The other thing you may want to do or quickly review before we get started, I just jotted down some of the reference info from earlier in this unit in particular that we're going to use on these examples. I kind of replicated a quick little end behavior chart, and we can grab that from earlier in our notes. So just keep in mind positive, negative leading coefficients, even versus odd degrees here. Excuse me, here. I jotted down some reference info about multiplicity. If it's an even multiplicity, for the zeros, it's going to bounce, odd's going to cross. And then something a little new, but I wanted to jot it down as a piece of reference info, is that when we find our y-intercepts on these, we're going to be doing that by plugging in x equals 0. So if you want to pause, jot this stuff down so you've got it handy, and then come back and get started. I'm going to zoom out a little bit so we can still see that part there as well. All right, so let's get started on example A. We'd already talked about the degree. Quick recap, the degree you add up your multiplicities for each of your factors. So these each have a multiplicity of 1. 1 plus 1 plus 1 would give me a degree of 3. All right, let's talk about end behavior. Remember, end behavior was based on the degree of the polynomial and the sign of the leading coefficient. So the degree here, because it's a degree for the polynomial of 3, that's an odd degree. And then because there isn't a negative up front, if you were to multiply that all through, it would have a positive leading coefficient. So it's an odd positive polynomial. So odd positive is down up. All right, let's do degree and end behavior over here. This one, if you watched the last video, was a degree of 4 because I've got 1 times 1 times 1 times 1 plus 1 plus 1 plus 1, x times x times x times x. Either way you do it, you'll get a degree of 4 there, which means it's an even degree. It is also positive, so if I do even positive end behavior, that's up, up. Okay, so that's degree and end behavior. Let's do zeros here. Your zeros, remember in the first video, the intro video, I showed you can take those factors, set them equal to 0 and solve them. So this first 0 would be positive 2, negative 4, and negative 3. We also have to state their multiplicities. So each of these multiplicities, there's only one copy of each of those factors. So I'm going to say multiplicity of 1 for each of them. And if you think about how that's going to apply to the graph, that's going to come in with how it'll behave at the graph. But we'll do graphing here in a minute. Okay, so my zeros over here, I actually have 4 zeros because I have 4 factors. This first one with just x there is going to give me a 0 at 0, 0, 0. And then I've got negative 2, positive 5, and positive 1. There's one copy of each factor, so the multiplicity is 1 on all of these as well. All right, y-intercept. I said in my reference info up here that we're going to plug in 0 for all of our x's. Because if you think about it, if I want a y-intercept, my x value would have to be 0 to be on the y-axis. So if I just plug in 0, I have 0 minus 2, 0 plus 4, 0 plus 3. Well, that gets me negative 2, 4, 3, and I'm multiplying between all of those. So negative 2 times 4 times 3, that's going to get me negative 8. Negative 8 times 3 is going to get me negative 24. So my point would be 0 for x and negative 24 for y. All right, let's try it over here. When I plug in 0 for all my x's, I've got 0 out front. Ooh, that's going to be important. 0 times anything is going to be 0. If you do it all the way through, you're still going to get 0. But as soon as you have x up front, when you multiply by a 0, 0 times anything is 0. So your y-intercept is 0, 0. Okay, now let's apply this all for our graph. I'm going to start by plotting all my zeros. So I'm going to mark positive 2, negative 4, negative 3, Okay. I'm also going to mark a point for my y-intercept, 0, negative 24. Well, actually, I can't really mark that. So it's somewhere down here on the negative side there. And then I'm also going to mark my end behavior. Now, the end behavior is going to take place all the way to the left of these points and all the way to the right of these points are where the graph's just going to continue. It's not going to be able to cross the x-axis anymore. So on this side, I'm going to mark an arrow pointing down, since on the left side I have down end behavior. And on this side, I'm going to mark an arrow pointing up. And then I'm going to start going from the left to the right and try and connect the dots using what I know about the multiplicities. Well, what do I know about the multiplicities and how the graph is going to cross the x-axis? Well, I know that all of these had a multiplicity of 1. That's an odd multiplicity, which means they will all cross at those zeros, since all the multiplicities were odd. So the graph is just going to cross straight on through. Okay, so that means I'm going to start at my furthest left 0 with an arrow pointing down. When the graph arrives at that 0, it crosses through, comes up, has to go back down, hits this 0, crosses straight on through. As I'm moving from left to right, the next thing I would have to hit is this y-intercept, somewhere way down here at negative 24. So it's going to pick that up, then it's got to come up, hit this 0, cross straight on through, and then carry on. And if my end behavior ends up matching what I predicted, then I know I'm in good shape. Okay, let's try that over here. Again, first step, plot all 4 of my zeros. 0, 0, negative 2, 2, 3, 4, 5, and 1. Again, all have a multiplicity of 1, so they'll all cross. My y-intercept's at 0, 0, so I already had that point, but it's good to know. And then end behavior is up, up. So I'm going to put arrows up and up on either side. Okay, starting all the way at the left. Since I have end behavior that's up and up, I've got to have an arrow pointing up from that furthest left point. What should it do here? Well, we said they're going to cross for all of them. So it'll cross straight through. Now it can't come towards the y-axis until it hits that y-intercept, because that's the only place it can cross the y-axis. So I got to come back, have it cross there, crosses through, I'll make it come right back down. We don't know how tall these loops have to be. You don't have to make them any particular height. We're just kind of trying to get a general picture of what this graph would look like. Okay, this one again is going to cross. And then who knows, maybe it goes all the way down here. Maybe it's a short loop, who knows, but it's going to come back up and cross here and cross right on through and go straight on up, and it again matches the end behavior I expected. So this could have just been like a W. It could have been lots of different things. We don't know exactly how tall those are. All right, there's our first 2. Stay tuned for the next video on our last 2 examples here.